Hello, everybody. We're talking about irrational numbers, and I have an interesting function here. And this function comes up a lot in areas where things are growing, like your money. Your money grows over time, and when you have your money in the bank, and then the first month they give you 6% interest, and then you have a new amount of money, and then that money grows by 6% interest, and then you have a new amount of money, and that so it repeatedly repeatedly multiplies over time, and that's what we call exponents, is repeatedly multiplying. So this number, this function crops up a lot in economics, where money grows, and also like in biology, where things multiply, right? So like the number of animals grow, and the number of bacteria grow exponentially this way. So I want to look at this and figure out what is the value of this function as it gets really, really big. So when n equals a big number. Okay, so let's try a couple of numbers. So let's make our table of values. So what happens when it's 1? I have 1 plus 1 over 1 to the first power. So this is 1 plus 1, which is 2 to the first power. So this is equal to 2. What happens when it's 2? So 1 plus 1 over 2 squared. So you can see what's kind of happening here. This number is going to get smaller and smaller, and this number is going to get bigger. So, well, let's just see. So 1 plus a half is 1.5, and it's squared. So let me get my calculator out. So I'll put this here. So 1.5 squared is 2.25. Okay, so what do you think is going to happen? It's going to be 1 plus a really tiny number, so close to 0. And this number is getting really big, so it's infinity. So what is 1 to the infinity power? Is it equal to, so 1 times 1 times 1 times 1 is just 1, right? So is it equal to 1? Is it going to turn around and go back to 1? Or is it going to get really big? Because this isn't quite 0, right? So if it's some number multiplied times itself a bunch of times, like if I took 2 times itself a bunch of times, it's going to get to be a really big number, right? So is this 1 to the infinity? Is it equal to infinity? So where do you think it's going to land up? Is it going to be 1 or infinity? Well, let's just try a really big number, about 100. So what's 1 plus 1 over 100 to the 100th power? Well, 1/100th is just 0.001, so I'll just say 1.01 to the 100th. And see there, it's 2.70. So even though I went up, 98 more, I only went up by about 0.5. Let's try a bigger number. How about 1,000? So 1.001 1,000. And see, I only went up to 2.71. And what about 10,000? And see, I'm still 10,000. I'm still only at 2.71. So this number that pops up in math on all these different places, we're going to give that a name. We're going to call it E. It stands for exponential. But that E value is 2.71828. And it's kind of like a number like pi. It's a constant number. It has a value. It's between 2 and 3. So E is between 2 and 3. And it's irrational. It doesn't have any pattern. It does have a pattern, just the first 2, some people write it like this. They put the bar over it, but it doesn't repeat. It does repeat once. 1828 repeats once, and then after that it goes and doesn't repeat. So let's see if I can e to the first power. Yeah. And you can see that it's 2.718281828459045. So after that, it doesn't have any pattern. So this is E, and it is it's in a special category with pi, transcendental numbers. So the transcendental numbers E and pi, they're kind of in a special category. The other irrational numbers, so E and pi are also irrational, but the other irrational numbers, examples of those would be, square root of 2, square root of 3. And there is a number that I'd like to bring up called phi. Phi is the diagonal of the pentagon that we saw before, and it was 1.618. And it can be written as a square root. It's 1 plus the square root of 5 over 2. So this is an irrational number, but it's not transcendental. And transcendental numbers are numbers that cannot be solved by algebraic equations. So if we have an algebraic equation like x minus 2 equals 0, the solution to that is 2, right? And if we have x squared equals 2, right, a solution to that would be the square root of 2. And we can play this little game, and we are going to play this little game, where we take a number and we try to turn it into 0 by only adding, subtracting, multiplying, or taking to the power of a whole number. Okay, so in this little game, we're going to take 2, and we want to turn it into 0. So what can we do with a whole number? We're going to add, subtract, multiply, or take to the power of to make it a 0. So all I would do is subtract 2, right? And then it turns into 0. So what about, let's take a fraction. How about 3/4? So what can I do to that number to turn it into 0? So I could multiply by 4, right? So 3 over 4 times 4 over 1. The 4's would cancel, and I'm left with 3. So this number is 3, and then I take away 3, and then we turn it into 0. Okay, how about the square root of 3? Well, I could take the square root of 3 times the square root of 3, which would be square root of 3 squared, and that would be square root of 9, which is square root of 9 is 3. So this turns into a 3, and I take away 3. So that's working. What about the cube root of 5? Well, I just take that to the 3rd power, and that turns into 5, and then I take away 5, and it equals 0. So you can see that these irrational numbers are all solutions. And by the way, this is the solution to the equation x cubed equals 5, right? So x could be the cube root of 5. So these are solutions to algebraic equations. Now let's just do phi, and that'll be it. But phi is equal to 1 plus the square root of 5 over 2. So how would I turn that into 0? Well, I would multiply this by 2, right? And then I would cancel out with that 2. And then I'd be left with 1 plus the square root of 5. So I would want to get rid of the 1. So minus 1. And then that would just leave me with the square root of 5. And now I would take this whole thing and square it. It would turn it into 5, right? And then I subtract 5 equals 0. So that works. And this is the solution to this equation, actually. X squared equals x plus 1. So we'll get to that later in algebra, but it's kind of something that pops up a lot. And what is a number times itself equal to 1 plus that number? It happens to be this special number we call phi. Okay, so all of these numbers work on this game. The numbers that don't work on the game are pi and e. And to prove that, it took a long time. And some mathematicians worked on it for years and years, and it wasn't actually proved until just recently in the 20th century. And a lot of the stuff that we talk about in math happened way earlier than that, like Archimedes in 250 BC. So anyway, you're going to play this game.